Next, we're going to look at the effects on the atmosphere and on insolation. Ionosphere is located in the thermosphere and the upper mesosphere. This is the area that contains ozone. Now, lower ozone is bad for your health as far as your lungs. Upper ozone actually protects us from UV or ultraviolet rays along with X-rays. So it's actually going to, it protects our health. So remember, the upper mesosphere is where you're going to have your ozone that's protecting us from UV rays along with X-rays. Stratosphere. Now, the stratosphere is, we hear a lot about climate shift, climate change. The stratosphere actually is where you have your greenhouse gases, be it carbon dioxide, methane, water vapor in the lower part of the stratosphere. These greenhouse gases absorb infrared. When you absorb infrared, it causes the temperature to increase. So I want to look at your reference table really quick. So I need you on page 14 of your reference table. So we're looking right here. The lower part of our atmosphere is the troposphere. Then we have the stratosphere, mesosphere, thermosphere. Now if I'm looking over here altitude-wise, on the left-hand side is in kilometers. So each little line is going up by 10. So 10, 20, 30, 40, 50, 60, up, all right? The other side, the right side is miles, it's going by 5. So 5, 10, 15, 20, 25. So your little dots are your pauses, or it's your interface between your different atmospheres. So if I look at my troposphere, notice as I go up in altitude, my temperature drops. When I go up in altitude for the stratosphere, my temperature is increasing because it's got the greenhouse gases in it. So this is actually absorbing infrared, so it's actually going to make it warmer. Also note on this one, as I go up, my pressure is going to decrease. I don't have as much pushing down. And then all the way over on the next part is my water vapor. Notice, once I get up into the upper stratosphere, I do not have water vapor. Most of our water vapor is going to be in the troposphere. Troposphere is where your weather takes place. Back to your notes. All right, we've talked absorption, now we need to talk about reflection. Remember, in 8th grade you talked reflection, you're bouncing back. So the angle it comes in at, all right, is your angle of incidence is going to equal your angle of reflection. So whatever angle it comes in at, it's got to bounce back at. So 34% of your insolation that reaches the Earth's atmosphere is reflected back before it actually gets to the ground. All right, since the ground doesn't absorb everything, that's actually going to keep us cooler than we would be if it actually absorbed all of it. So 34% of it doesn't get to the Earth. The lower the angle of the insolation, the greater the reflection. All right, so the lower it's in the sky, the more I'm going to reflect off. So sunrise, sunset, all right, during the wintertime, I'm reflecting more than I'm actually absorbing. Scattering means it's just going in all different directions. Scattering is caused by things like pollution in the air, be it volcanic ash. So we have a volcano that erupts, like we looked at Mount St. Helens earlier this year. Dust, any kind of pollutants or aerosols that are in the air. The scattering is going to also keep our temperature cooler. So when we had talked earlier this year about when you had the mini ice age in the 1800s, that was because of volcanic eruptions, that ash in the air doesn't allow the sunlight or insolation to actually get to the ground. So that way it keeps us cool, and that's why they had that mini little ice age in the 1800s. Albedo effect. White reflects light. So snow or glaciers are going to reflect the visible light. 6% of the Earth's surface is currently covered by snow or glaciers. It's going to keep the temperatures cooler. Here's our problem. With climatic shift, the higher latitudes are actually warming up. So that means we're having more snow melt or more glaciers are melting. As we have more of that melting, our albedo effect is going to go down. So with that, we actually are going to warm up even more. Another thing, the sun penetrates further into water than soil. So the energy is going to get equally distributed into the water. All right, you're going to heat the top of the soil much more than you are going to as you go down. Okay, little reminder. You're going to be doing this one in chemistry next year. Heat energy gained or lost equals the mass of the object times the change in temperature times specific heat. Now, I got to remind you, where do you find your specific heat? First page of your reference table, upper right hand corner. Reminder, specific heat, amount of heat energy needed to gain or change, I say, amount of heat energy needed to change 1 gram of a substance 1 degree Celsius. So I need to be able to heat it up 1 gram of substance 1 degree Celsius. The higher your specific heat, the more energy needed to increase that temperature. The lower the specific heat, the less energy needed to change that temperature. So if I look at what we have given on your reference table, lead will change a lot faster, heating and cooling, than any of the other substances listed, where liquid water takes the most energy to heat or cool. So it's going to take longer. All right, so going back to your example, I need you to do a little math. 100 grams of granite went from 20 degrees Celsius to 50 degrees Celsius. What is the amount of heat energy gained? So I write down my equation again. Heat energy gained equals the mass, what we said is 100 grams, times the change in temperature. I went from 20 to 50, a difference of 30 degrees Celsius. Your specific heat, it got right off your reference table, page 1, 0.79 joules per gram degree Celsius. When I multiply that all together, I get 2,370 joules, because the grams and the degrees Celsius are going to cancel out. All right, just a little reminder again, your specific heat values, you're going to use your reference table.